All right, let's try to finish up this section. So example 3 is where we kind of ended up yesterday. So let's do that one. And we got a couple more to do. I think we just have examples to do. Nah, there's a little bit more at the end. It's not real hard, but a couple examples, and then we'll look at the one on the end. So Simone requested blue, so we'll use blue. It says write an equation of a line. So let's write that down. Write an equation of a line. Now there's two different ways we could write an equation of a line. Do you remember? Slope-intercept form, right? That's the y equals mx plus b. And then what was the other one? The standard form, okay? Now this one, I don't know. Anybody got their book open? Look at the example for example 3. Does it tell you which way to write it? I didn't put that on my notes. So sometimes they'll tell you. Sometimes they'll say, write the answer in standard form or write the answer in slope-intercept form, okay? So just in case. All right. So let's put this in slope-intercept form. Y equals mx plus b. All right. Oh, through what? We got to put some stuff here. Through negative 5, 6. And the slope is negative 1/2. All right. So let's write the equation down. Y equals mx plus b. Now, we know what a couple of these things stand for, okay? The m stands for the what? The slope. What does the b stand for? The y-intercept, okay? One thing we didn't talk about, but it's important in this problem right here, is this x and this y. The x and the y in this formula stands for any point that could lie on the line itself, okay? It's not just the x-intercept, it's not just the y-intercept. It could be any point that actually lies on that line, okay? Do you hear what I just said? So this x and y, because remember, xy is an ordered pair, isn't it? And that's a point. So this x and this y represents a point that lies on the line. So if I had a point that actually lied on this line right here that it's describing, you could put the x coordinate here and the y coordinate here, and everything would equal each other. All right. So do I know a point that lies on this line? Sure I do. What is it? Negative 5, 6. Very good. Okay. So that means, where am I going to put that negative 5? In for what? In for the x. So I'm going to put the negative 5 in for the x. Where am I going to put the 6? In for the y. Okay. What's the only thing I don't know here? The y-intercept. So guess what we're going to solve for? The y-intercept. That's right. Everybody got that? So I can put all these numbers. See, I'm going to put a negative 5 in for the x, a 6 in for the y, and a negative 1/2 in for the m, or the slope. Then I'm going to find the y-intercept. Once I find the y-intercept, they've already told me the slope, right? And that's really the only two things I know to get the equation of a line. Would you agree? Is the y-intercept and the slope. So that's what I'm going to do. I'm going to find the y-intercept, and then I can write it all nice and neat. Y equals whatever the slope is, which we know it's negative 1/2, they told us, and then plus whatever the b is. All right, so that's the work. The work is to find the y-intercept. All right, so let's plug everything in. What am I going to put in for y? We already said it once. Put a 6 equals m. What's the m? Negative 1/2, right? Times the x. What's the x? I'll just put a dot. The x is 6. Oops, what am I doing? What am I doing? Let's get rid of this ugly looking dot. Let's try to put a better dot. Okay. And times what? Negative 5. I'm going to put it over 1 since I'm multiplying it by a fraction. You okay with that? And then plus what? Plus b. So I got to solve for b. All right? So what are we going to do? Well, let's multiply this together. Well, first of all, what's a negative times a negative? It's positive. So what's 1/2 times 5? 5 over 2. Do not change that into a decimal, right? Don't change it to a mixed number either. Keep it improper, right? It's a lot easier to add, subtract, multiply, and divide fractions when they're just a fraction and it doesn't have a whole number in front of it. Everybody understand that? Okay, I think so. Most of the time, maybe not every single time, but the vast majority of times, I would rather deal with just a fraction, just a numerator and denominator, if I'm adding, subtracting, multiplying, and dividing. All right, so I am not going to change that to 2.5. I'm not going to change it to 2.5. I'm going to keep it 5 over 2. We good with that? All right. Plus what? B. So I got to get B by itself. So what do I have to get rid of? What is it? I can't hear you. You got to speak up. The B is good right where it is. Because if I move the B to the left side, then I get a negative B. I don't want to have to deal with a negative, right? So let's just keep the B right there. So what do I have to get rid of? Not how do I get rid of it. What do I have to get rid of? The 5 over 2. Very good. Okay. Do you not see that? Is it because it's a fraction? Is that why that messed us up? I don't know. Well, anyway, we got to get rid of that 5 over 2. Now, this is a positive 5 over 2. It's being added to this. So how do I get rid of a plus 5 over 2? I subtract a 5 over 2. Then I come over here and I subtract a 5 over 2 from this. All right, that cancels out. What am I left with on the right-hand side? A B. Now what do I have to do? Got to do fractions, okay? So what do I do when I add and subtract fractions? What's the most important thing to do? Find a common what? Denominator, okay? So what would the common denominator be? It's 2. So how can I rewrite this as with a denominator of 2? 12 over 2. Do you agree? All right, there's all kinds of ways that people can teach fractions. At this point, I mean, this should be easy enough, is it? To subtract these? All right. Well, that's why you were taught it a long time ago, so that you could use it now. All right, so we subtract a 5 over 2. It makes it a little easier to subtract because I got a common denominator. So what do? I just keep the denominator the same, right? I don't subtract those, and I just subtract the numerators, the top. So 12 minus 5 is what? 7. So my y-intercept is 7. Now, if I was to graph it, then I would want to look at it as an improper or a mixed number, okay? So what is 7 over 2 if I was to graph it? 3.5, right? So if, I'd go to my grid mark over 3, then I'd go over half a grid mark, right? Or it would be in the y, it's the y-intercept, so it would be actually up. I wouldn't go over. All right, so I'm almost done. What do they ask you to do? Write the what? Equation of a line. So how do I write an equation of a line? Y equals m. What's the m? Negative 1/2. They told that to us, okay? So that was nice. And then what? X. And then the b. What's the b? It's positive 7 over 2. So I put what? Plus 7 over 2. That's my answer right there. Okay? Think you can do something like that? Yes? No? Yeah. What was the hardest part? Just the fractions? All right.
Wait, so is x-intercept is where it crosses
the x-intercept is where it crosses the x-axis. Okay, but that's not what this is. Okay, yeah. So this doesn't really have the x-intercept in it. The only thing this has in it is the what? It's the y-intercept, okay? And the slope. So those are our two things, the slope and the y-intercept. They told us the slope. All we had to do is find the y-intercept. Then you put it all together nice and neat. Y equals mx plus b. Our m is negative 1/2. Our b, our y-intercept is positive 7 over 2. Put it all together, a nice little package, and then there it is. And you could graph this if you wanted to, couldn't you? Yeah. Now, where's the y-intercept, though? We just said it. It's what? 3.5, right? So you got to go up 3 and then half of 1, all right? It doesn't ask you to graph it on this problem, so that's okay. All right, now this one. Do you remember the other day? I don't think it was this lesson, but it might have been another lesson. We talked about parallel and perpendicular lines. What's true about the slopes of lines that are parallel? They're the same, okay? So the slopes are the same. What if the two lines are perpendicular? What's the slope? Or it's a negative what? Reciprocal, okay? So negative reciprocal. So keep that in mind. We learned that because of what we're going to do right now, okay? So we learned that before, so we can do this. So this is example 5. It says, write an equation of a line through point P. So, that's parallel to K. All right, I got it. So I guess that one is K. I didn't write, yeah. I don't have the book open. I just have my notes. They do put a graph there, don't they? On example 5? Okay, I was just making sure. And I'll tell you what, let's use this graph right here. Copy that. Let's bring it down here. All right, that's good enough. All right, so here's what they give you. It looks like it goes right through the origin, does it? Did they give you like points? I really should have my book open. Let's take a look at it. Because I wrote it down in my notes. 3.5. Let me take a look at 3.5 and example 5. Oh, okay. Yeah, so you just have to count. They do give you point P, and then you can find the slope. Okay. So here's what they do. Let's do this. We'll make this red. I like to make the lines red because a red line, right? Red lion, red line. You get it? Okay. Sorry. Dad joke. Sorry. All right. What's that? 2, 1. So go up 2, go over 1. Does that look like that in your book? Yep. Looks like it to me. And then point P is what? -3, -1. 1, 2, 3, -1. Okay, so that's point P. We're going to use that in a second. But let's do this. Let's draw this line right here. Now, if this goes up 2 over 1, if I wanted another point on here just to make sure I get it lined up right, then what can I do here? I could go up 2 over 1 here. Everybody see that? Because that's your slope, isn't it? All right, and then I could go up 2 over 1. I could keep doing that. They should all line up. Would you agree? I could go down 2 to the left 1 as well. Agreed? So I'm just going to connect all those like that. I'm going to extend this one up just a little bit more. Yeah, there we go. All right. So here's the deal. Oops, come on. There we go. Let's see. It says write an equation of each line that goes through P that's parallel to K. K is this line right here, this red one. So that's line K. We want to find an equation of a line that's parallel to this line that goes through P. Everybody see that? So if I wanted to draw it, what would it look like? It'd look kind of like that, wouldn't it? All right. But I want to find the equation of that line. And I'm going to do it without graphing it. Okay? So what do we know? Well, first of all, let's do this. Do I know the equation of this red line? Well, I can look at it and figure it out. What's the y-intercept of that red line? 0. Yeah, there is one. It crosses the y-axis. This is the y-axis. Where does it cross the y-axis? Right at 0. So there is definitely one. All right. What's the slope of it? We already talked about that. It's 2 over 1, right? So 1, 2, 1, right? I just looked at my graph, right? I counted up and over. And in the book, they actually have this graph paper thingy, right? So there's no guessing. Would you agree? Go up 2 over 1. So the y-intercept is 0, and the slope is 2 over 1, or just what? Just 2. So I can find the equation of this red line. So what would that be? Y equals m. What's my m? 2 what? X plus what? 0. Do I need the plus 0 there? No. So what's the equation of that red one? It's that one right there. It's just y equals 2x. Okay? Everybody with me? So now what we're going to do is we're going to find the equation of a line that is parallel to line K, this red one, but it also goes through point P. Well, let's find out where point P is. Let's count over. 1, 2, 3. That's -3. What? -1. So what's that point? -3, -1. Everybody with me? So that's where that point is. So without using the graph and drawing it and counting and that stuff, let's just do some math over here to find the equation, because we want another line. I'll make it blue. All right? We want another line that looks like that. Would you agree? Because doesn't that look parallel? Yep. So we want to find the equation of that blue line. All right? I was off maybe just a tad, but it's pretty close. But I want to find out exactly what it is. How in the world do I do that? Well, I know the slope of the red line. What's the slope of the red line? It's 2. So what's the slope of the blue line going to be? It's going to be the same thing. Why? Because the lines are parallel. Very good. Okay, so the blue line, I know the slope. I know the slope is 2. What do I have to find? I got to find out where it crosses where? The y-axis. I could look at the graph and just guess, because it doesn't look like it goes right through one of these little grid mark intersections, does it? All right, so I could guess, but let's not guess. Let's do it. So I know a point that lies on that blue line. That's point P. What is that point? -3, -1. Now I'm doing exactly what I did in that last example. Does that make sense? All right, so I got a slope, I got a point. Now I can make an equation out of that line. So let's do it. It's y equals mx plus b. What am I going to plug in? What's the y going to be? -1. What's the m going to be? 2. Times x. What's the x? -3. What am I solving for? B. Right? Now I know where the b is. The b is going to be right there, right? Would you agree? But I want to know mathematically, okay, exactly where that's going to be located. I could guess, all right? And you might be right if you guess, but I want to know for sure. So let's solve for b. This is easier because I don't even have a fraction here. So -1 equals what? -6 plus b. Keep the b over here on the right-hand side. Let's get rid of the -6. I add a 6. I add a 6. And then what do I get here? 5 equals b, or b equals 5. Doesn't matter. So my y-intercept, oops, did I do that right? Yes, I did. Oh, what did I say? I circled that. That was dumb. Yeah, somebody tell me. If you see something, because look, I make mistakes a lot. All right, so if you see something I misspeak, let me know. This is the y-intercept right here, correct? All right. Now again, I might have not drawn it. It looks like it's tilted a little bit. It doesn't look like I drew it exactly the way I should have, but that's okay. We've got it right here. So what is the equation of the blue line then? It's y equals what? 2x what? Plus 5. So that's the equation of that. So that means the y-intercept is where? It's at 5. 1, 2, 3, 4. Oh, I really messed up that line, didn't I? I should try drawing that again. All right, so let's try to draw that. What am I doing? I want to scooch down a little bit. There we go. All right, so it goes through this point. What's the slope of it? 1, 2, 1, right? Right there. 1, 2, 1, 1, 2, 1. So I could do that, right? That's the slope. So now I know that it hits exactly right there. So I just didn't draw it very accurately before. So that looks a little bit better. And kind of goes like that. So there you go. Now, we still didn't finish this lesson. My goodness, I'm so slow.
Teachers, you'll be dismissed at 1 o'clock today for the pep rally. And the 2023-2024 homecoming court for 9th grade. The girls are Simone Arkhart.
Yay, Simone.
Autumn Truskowski. 9th grade boys. Makai Corbin. Zion Reddick.
Zion.
10th grade girls. Hannah Pargo and Taylor Radel. 10th grade boys. Judah Barber and Seb Idahosa. 11th grade girls. Rose Tanyos and Gael Wilson. 11th grade boys. Kevin Arkhurst and Wayne Robinson. 12th grade girls. Morgan Areola. Ella Lake. Anastasia Pargo. Sarah Taylor. 12th grade boys. Shane Caleb. Sam Crossan. Nico Sarson and Landon Washington.
Okay, so what if I wanted to find a line that's perpendicular to the red one? Let's do this in a different color. Let's go yellow. Come on. There we go. What if I want to do a line that's perpendicular to the red one and it also goes through point P? All right, so let's just kind of draw what it might look like. I'm not going to be super accurate, but it would probably look like something like that. Something like that, maybe? Would you agree? Does that look perpendicular? Does that look perpendicular? Maybe something like that, maybe. Yeah? So I got to find the equation of that yellow line right there. And it's perpendicular to the red one. All right, and it goes through point P. Now, if it's going to be perpendicular to the red one, it's also going to be what? Perpendicular to the blue one. Agreed? All right. So what is going to be the slope of the yellow line? If it's perpendicular to the red one, I should know automatically what the slope's going to be. Is it going to be the same? No, it's going to be the what? Negative reciprocal. And what is the negative reciprocal of 2? It's negative 1/2. So basically, that's the only thing different about finding the equation of a line that's perpendicular compared to parallel. Parallel, you just use the same slope, right, as the other line. Perpendicular, you use the negative reciprocal of it. So we could draw it out, couldn't we? So it's negative 1/2. So I go down 1 and to the right 2. Yep, I drew it pretty accurate, okay? Down 1 over 2. You see how it all lines up like that? Yeah, and I could extend it if I wanted to. Might as well. Like that. So what I want to do is I want to find out where the y-intercept is, though, because I want to find the equation of that yellow line. I know the slope is negative 1/2. So what am I going to do? Let's do it real quick now since we've already done it once. Oops. Every day I mess that up. So y equals mx plus b. The y is going to be the same, right? Because we're talking about that point P. So we know a point that goes through that yellow line. It goes through point P. So -3, -1. So that's a -1. The slope is negative 1/2 times the x. What is the x? It's -3. I'm going to put that over 1 plus b. So it's -1 equals, that's positive 3 over 2. Agreed? Then we subtract a 3 over 2. Subtract a 3 over 2. So that cancels. We get a b right there. What's this going to, let's rewrite -1. How are we going to write that? Negative what? 2 over 2, right? Because you got a denominator of 2. So what's -2 minus 3? What's -2 minus 3? Negative what? 5. -2 minus 3. Add a line, change the sign. It's -5. All right? So it's -5 what? Over 2. That's the y-intercept. What is -5 over 2? It's 2.5, right? Negative. And is that where it's located? 1, 2.5. Yep, right there. Okay, so it all works out. So what's the equation of that yellow line? Y equals m, which is -1/2, x, and then minus, don't put 2.5 though, put 5 over 2. All right, so that is the equation of the yellow line. Okay. I think actually we've already talked, I told you the story about me repelling, right? So what's the slope of a horizontal line?
0.
It's 0. Okay, what's the slope of a perpendicular line? It's undefined. Okay, now we are officially finished section 3.5. So any homework that I've given you on that lesson plan thing on 3.5, get that done, turn it in tomorrow. Okay, and so whatever I've given you on 3.5, did I just give you one assignment or did I give you 2? I can't remember. Just the one? All right. Is it 2 of them?
Oh, yeah.
Is there an A and a B? Okay. So get that done for tomorrow.